Hello everyone, welcome to my presentation. I am dealing with the subject Power Plant Engineering. In that topic is Steam Power Plant. The outline of my presentation is burners, classification of coal burning methods. This is the burner. Burners are used to burn the pulverized coal. The main difference between the various burners lies in the rapidity of air cooling mixing, that is, turbulence. For bituminous coal, the turbulent type of burner is used, whereas for low volatile coals, the burners with low flame or long flame should be used. A pulverized coal burner should satisfy the following requirements. It should not mix with fuel-air ratio of 8. That is, it should mix the coal and primary air thoroughly and should bring the mixture before it delivers the furnace in contact with additional of air known as secondary air to create the sufficient turbulence. It should deliver coal and air to the furnace in right propagation and should maintain stable ignition of coal air mixture and control of flame shape and travel to the furnace. The flame shape is controlled by the secondary air valves and the control adjustments is incorporated into the burner. Secondary air, if supplied in too much quantity, may cool the mixture and prevents it heating to ignition the temperature. Cool air mixture should move away from the burner at a rate of equal to flame front travel in order to avoid the backflash into the burners. And some of the conditions are enough time to burn the fuel completely, high temperature flame, turbulence mixing of the fuel, proper propagations of furnace dimensions. Classifications of the burners. Depending upon the method used and rapidity of air-fuel mixing, that is, turbulence, pulverized fuel burners are classified as 4 types: long flame burners, turbulent burners, tangential burners, and cyclone burners. In that, first one is long flame burners. Long flame burners are also known as U-flame burners or streamlined burners. In this, the arrangement of primary air and the coal and the supply of the secondary air, that is secondary air. Primary air of coal and secondary air are supplied to the as shown in the figure. In this system, the burner discharges the air and fuel mixture vertically with particular no turbulence and produces a long flame. Heated secondary air is introduced to right angles to the flame, which provides for better mixing and rapid combustion. If we need an additional air, tertiary air is entered. And the long flame provides sufficient time for complete combustion. So this is primary air and coal, and we are adding the secondary air, and this is the flame, and the flame is in the turbulence. And another form is primary air and coal is entered here, and the secondary air and the flame is in tangential. Here if we observe the two diagrams, the direction of flame are right angles to each other and the angles are varying here. And second one is the turbulence burner. Turbulence burner is also known as short flame burner. These burners are usually fitted into the furnace wall and projected the flame horizontally. The fuel and air mixture and the secondary hot gases are arranged to pass through the burner in such a way that there is a good mixing and the mixture is projected in highly turbulent form in the furnace. Due to the high turbulence created before entering into the furnace, the mixture burns intensively and the combustion is completed in a short distance. Modern power plants prefer this type of burners as this type of burner gives the high rate of combustion when compared to the other types. So there are three types of burners based on the Reynolds number, that is laminar, transition and turbulent. So these are in this we discussed about the turbulent burners. And the third type of burners is tangential burners. So in tangential burners, the pulverized coals enters here and the secondary air entered here, and this is the tangential circulating. So burners are set in the furnace corners and directed tangentially to the imaginary circle at the center of the furnace. So this is the center of the furnace. So these are the four corners. From the four corners the burners enters here and this forms the tangential. The burners are set in the four corners at the combustion chamber at such that an angle that the direction of the coal and the stream leaves the burners lies horizontally and tangential to the circle of about 0.6 meters. This promotes a vortex or swirling action in the flame, gives the rise in the turbulent, which ensures complete and rapid combustion of the fuel, and effective and uniform distribution of the radiation. Secondary air enters into the box, ensures the burning nozzle. So this is the working of the tangential burners. And the fourth type of the burner is the cyclone burner. So in this type, the coal and air get mixed in the cyclonic. So coal and air mixes, primary air and coal get enters here and it mixes in a cyclonic way. This is the secondary air and this is the cyclocylinder and the molten ash is collected here. Hot gases are coming out. This is the furnace. The coal is crushed into a tiny particles in addition to the pulverized coal. This ash is completely collected due to cyclonic action. The cyclonic burner receives crushed air, coal carried in the primary at 80 centimeters of water pressure at the left end. Tangential entry of the coal throws it to the surface of the cylindrical furnace. Secondary air enters into the furnace through a tangential port at the upper edge of the high speeds and creates a strong and highly turbulent vortex. Entirely high heat liberation rate and use of preheated air with high temperatures to turn 2000 degrees in the cyclone. The fuel supply is quickly consumed and liberated ash forms a molten film flowing over the inner layer of the cylinder. This is the inner layer of the cylinder. Due to the horizontal axis of the burner being tilted, the molten ash flows to the appropriate disposal systems. The cyclone furnace gives best results with low-grade flames. Cyclone burners in this system, the cyclonic action drills the coal and air against the walls of the furnace to facilitate through the mixing of coal and air. And the advantage of the burner is that it can also use crushed coal in addition to the pulverized coal, thus providing an option. When crushed coal is used, ash is collected in the molten form for the easily disposal. It also saves the cost of pulverization because of a crusher needs less power than the tangential. The problem of the fly ash is reduced ash produced in the molten form, and due to inclination of the furnace, it shows to an appropriate disposal systems. And the advantages of cyclone burners are: cyclone burners are costly pulverizers and not required. Instead, that simple coal crushing equipment can also be used. By using forced draught fan, it can operate with small quantities of excess air. It can burn low grade of coal effectively. High temperatures are obtained. Boiler fouling problems can be reduced as all in combustible are retained in the cyclone burner. Boiler efficiency also increases. And another type is cyclone fired boilers. In cyclone fired boilers, the furnaces are arranged in horizontal cylinders. The pulverized fuel is bed along with the periphery of the cylinder. The hot gases travel axially into the water tube section, having a tight helix path. The temperature generated in the combustion zone is quite high, and because of these tubes are coated with fused ash, which goes on collecting the ash particles going in the flue gases. The outgoing gases contain the particles less than 20 microns. The cyclone furnaces can successfully burn coal having low ash fusion temperature. The cyclone furnace is operated under the combustion air pressures of 700 to 1000 mm of water gauge. Cyclone fired boilers having the advantages of quick load variation can be easily handled. Nearly 85% of ash in the coal is burned in the form of liquid slag. The ash can be removed in the molten form. The slag can be used as a building material. Fly ash problem is reduced much than the lower limits. Another type of burners is also there, that is fuel oil burners. Fuel oil burners, in that vaporizing or operating type burners and atomizing burners are used. Atomizing burners are again broadly classified into steam burners, mechanical atomizations, and in that fuel oil and the gas supply arrangement also there. Another type of burners is gas burners. Gas burners are used to mix air and fuel gas in the desired propagation, being ignition. Gases are as a fuel has the following advantage: it can be handled easily, furnace temperature can be easily controlled, there is no pollution. There are two types of the burners. A long frame results by showing the burners when both the gas and air are under pressure burners. For burning the gas, no atomization is required. Combustion of 1 meter cube of natural gas requires appropriately 20 meter cube of hot air. Proper mixing of gas and air can be ensured by introducing the gas into the airflow in the form of thin jets of high pretension. Because of good mixing of excess air required for combustion is less. Nowadays, combined gas fuel oil burners are also used because of the advantage of the change from one fuel to the another can be done quietly easily, and both the fuels can be burned under almost optimum conditions. The mixture of the gas and fuel oil is ignited by electric means. So these are the various types of the burners we are used for the combustions in steam engines.